Welcome to day 3 of our series on programming languages. Today we will dive into lexical analysis, the first phase of a compiler. Let's explore how source code is transformed into a format that's easier for a compiler to understand. Lexical analysis is the process of converting the raw source code into tokens, the smallest units of meaning. It's the first step in compilation, where the input code is broken down into manageable pieces for further processing. A lexer, also known as a lexical analyzer, plays a key role in this phase. It scans the input source code and identifies meaningful units tokens. By simplifying the input, it makes it easier for the parser to handle the syntax of the language. Tokens are the building blocks of a program. They represent the smallest meaningful elements of a programming language. For example, keywords like int, operators like equals to, or variables like x are all considered tokens. Lexemes are the actual character sequence that match a token. For example, in the token identifier, the lexeme could be x. Each token has its corresponding lexeme, which is extracted from the source code. Regular expressions are crucial when defining patterns for tokens. They help match specific character sequence in the source code. For example, we use regular expressions to identify keywords, identifiers, numbers, or operators in the text. Here are some examples of regular expressions used in tokenization. For example, we might use patterns like if, else, or while. For identifiers, a regular expression could look like AZ, A to Z, A to Z, A to Z 0 to 9 star. And for numbers, it's as simple as 0 to 9 plus. Lexical errors occur when the lexer encounters characters or sequences that don't match any valid token. Common errors include invalid characters or using reversed words incorrectly. These errors need to be handled carefully to avoid disruptions in compilation. There are several strategies for handling lexical errors. These include skipping over invalid tokens, logging warnings and errors, and in some cases, gracefully terminating the compilation process if the error is severe. Let's look at the basic algorithm for lexical analysis. It starts by reading the source code and attempting to match it to predefined patterns. Each match corresponds to a token, and once matched, it is added to the list of tokens. Lexical analysis also involves ignoring white space and comments, which are not necessary for the next phase of parsing. If the lexer encounters unmatched patterns, it reports them as errors and either skips or stops processing. Here's a simple Python lexer code example. It defines a function that reads the input source code, matches it to predefined token patterns, and generates a list of tokens based on the matches found. As you can see, the lexer function processes the input code character by character, matches it against various regular expressions, and creates a list of tokens, skipping over whitespace and comments. Here's an example of the lexer. For an input like int x equals to 42, the lexer generates a list of tokens keyword, int, identifier, x, operator, equals to number, 42, and unknown, semicolon. Lexical analysis has a number of important applications. It helps with pre-processing by removing comments and handling macros. It also plays a crucial role in syntax highlighting in integrated development environments or IDEs. Additionally, lexical analysis helps simplify input for the parsing phase and contributes to code optimization by detecting early errors in the code. There are several tools available for lexical analysis. Lex and Flex are popular tools for generating lexers. In some programming languages like Python, you can implement a lexer using built-in regular expression libraries. Lexical analyzers often work in conjunction with other tools, such as parser generators. For example, lexical analyzers are often integrated with tools like Bison or Antler to form a complete compiler pipeline. In conclusion, lexical analysis is a critical step in the compilation process. It helps break down source code into manageable tokens, making it easier for subsequent phases like parsing. Understanding tokens, regular expressions, and error handling is essential for building efficient compilers.